vertex form. To write in vertex form, we have to complete the square, but we have to complete the square only on one side. And in order to complete the square, you only can complete it for 2 items. So we're specifically looking at this section right here. What does that 2 need to turn into? I can't do it with the 2. What do I need instead?
Oh, you need a 1.
I need a 1. And what are we going to do to get that 1? Yeah.
You divided the 2x squared minus 1 is 2.
Divide or factor out, right? Yep, factor out. Same thing, because when you factor out, you're dividing out. It's the exact same thing. So our next step would be to write this basically as f of x equals pulling out a 2. We would have x squared minus 2x plus something. Leave all that in the parentheses, and then we have a plus 18 hanging off of the end. Now what we add in there to complete the square would be that b over 2 squared. So we'd be adding that b over 2 squared, which is negative 2 over 2 squared. But we have to add that back in there. But on top of that, because this 2 would factor there, this 2 would have to factor here. So realistically, we'd have 2 times negative 2 over 2 squared. And that's it. Now it's basically in vertex form. We just have to simplify stuff. So we're going to bring down the x, and we'll bring down that negative 2 over 2, which is negative 1. Leave the square on the outside. This right here, negative 2 over 2 is a negative 1. Negative 1 squared is a positive 1. So this is just 2. This is 18. What did I do wrong? Yeah.
Would you subtract the 2?
We would have needed to subtract that 2. Because it's not balanced right now, right? Because I basically added the same thing twice. You would need to, since we added this negative 2 over 2 squared, we have to subtract away in the next one. Yeah, so you definitely need that subtraction outside. So we'd have 18 minus 2, which would equal a plus 16, which would lead us to have the vertex of not negative 1, but a positive 1, comma, 16. Remember, this value, when I plug it in, I better get 16 out. And when I plug 1 in here, we have 1 minus 1, which is 0. 0 squared is 0. 2 times 0 is 0, plus 16 leaves us with 16. This first number should always make the thing in parentheses become 0. All right, questions on that? All right, then questions from the homework. Yeah, we're Number 3 and 4. And what specific questions do we have, I guess?
My numbers just weren't coming out right.
Your numbers weren't coming out. What particular numbers, I guess?
When I was trying to graph the first one for the most part, I couldn't get the axis of symmetry to line up with where I was calculating the points.
Oh, okay.
With the other one, I was just having trouble finding the x-intercepts.
So what did we get for, I guess, our axis of symmetry on number 3?
I got 3 over 4.
Okay. Yeah, all right. So we'd have... So we'd have an axis of symmetry for number 3 would be x equals 3 over 4. That was our axis of symmetry. So if I was to do a very rough sketch of this, 3 over 4, so let's make this, I guess, 1. And then 3/4 would be somewhere about here. So let's do our dashed line about here. All right, then we take our axis of symmetry, and that's going to become my vertex, right? So our vertex would be 3 over 4, comma, plug in 3 over 4. When we plug in 3 over 4, we'd get 2 times 3 over 4 squared minus 3 times 3 over 4 plus 1. And unless my math is wrong, does that come out to a negative 1/8? I don't have the actual math here. I just have what I got. Is that good? Was that okay? Or did you get a different number there?
I got 1/4.
Oh, okay. Let me just double check. So, well, we can just do it. So we would have, let's pretend like I don't know that. Let's go ahead and we'd have 2 times, and we'd have 9 over 16 minus 3 times, so that would be 9 over 4 plus 1. Fun. All right, so we are going to have, well, this will become 18 over 16 minus 9 over 4 plus 1. We'd have to have a common denominator. Well, this can be 9 over 8 minus, this would become 18 over 8 plus 8 over 8, which would equal a negative 1 over 8. So that would be a negative 1 over 8.
Okay, got it.
Which will change your range and your domain, and then it would kind of... Did we get the right vertex form then?
I think so, yeah.
Okay. Probably just that negative 1/8 would have changed all your numbers.
All right, got it.
All right. And then for 4, we had problems with x-intercepts?
Yes, I just was having trouble calculating.
Okay. How were you calculating your x-intercepts, I guess?
I was just trying to use the 0 is equal to negative 2x squared.
Oh, okay.
Yeah.
Okay. So you came up with your vertex form as being y equals a negative 2, comma, or parenthesis x plus 1 squared. Looks like plus 10?
Yes.
Okay. Yes, that would be correct. Okay. So to look for zeros, we just replace y with 0. So we'd have x plus 1 squared plus 10. Well, I would subtract 10 from both sides, divide by a negative 2. So we'd have 5 equals x plus 1 squared. Correct?
Yeah, I think so.
Yeah. So I'd subtract 10 from both sides, and I would divide by a negative 2. So yeah, that would become 5 equals that. Take the square root of both sides. We'd have plus or minus the square root of 5 equals x plus 1. Subtract 1 on both sides, and we'd have an x equals a negative 1 plus or minus the square root of 5. And you didn't need to simplify it any further than that.
All right.
Did you have a question beyond that, I guess?
No.
You sure?
Yeah.
Okay.
Right.
Does that all make sense, though? Then?
Yes.
Okay.
Yeah, now I got it.
Okay. I just want to make sure I answered all your questions. But that's good on 3 and 4, then?
Yes.
Okay. Awesome. Other questions? Okay, today isn't an obnoxiously long lesson. We just have one really problem. It's the application one. But if you generally know how to do a general graph of a quadratic, you can solve quadratic inequalities pretty quickly. I think this is the most effective way to solve quadratic inequalities. And that is a couple of your zeros, rough sketch of your graph, and then just kind of shade in what's the correct answer and then give yourself an answer. So it says, solve x squared minus x is greater than 6. This is the same question, but it's going to make your life a little easier. Whenever I have it written like this, I'm going to rewrite it as x squared minus x minus 6 is greater than 0. All I'm doing is I'm subtracting 6 from both sides. Same exact problem, but it's going to make your life a lot easier. So I'm just going to go ahead and always rewrite it like that. Do I need to switch the sign when I'm subtracting 6 from both sides? Do I need to switch the sign when I subtract 6 from both sides? When's the only time I need to switch the sign? Rena.
When you divide.
Divide or multiply by a negative number. Yep. When I'm subtracting, everything stays the same. Do we all agree that these two things are the exact same? Everything's balanced. Everything's still good. This is just a lot easier to work with. And we'll see why down below. All right, this says, then determine the zeros of this function. So rather than looking for greater than 0, the first thing we're going to do is we're going to go, well, x squared minus x minus 6 equals 0. you can't do this if you stick with your original one. So we first have to solve for everything on one side and 0 on the other. And then we're going to say, when is it 0? When is it 0? Because then it's going to be a lot easier to come up with when it's bigger and when it's smaller. So when is it true, first of all? When does it equal that 0? Now, here's where we're going to have multiple options. We can either factor, complete the square, or use the quadratic formula. Generally speaking, if it's x squared minus x minus 6, my first bet isn't to use the quadratic formula. My first goal is to first see, is it factorable? Because this is something we can just kind of eyeball factor because it's super simple or small. So let's first just in our head kind of picture, is it factorable? As I'm writing it out, you probably know it is because I'm already starting to write it out. I'm looking for two numbers that multiply together to give me 6 and whose difference is 1. Well, that's just 2 and 3. All right, now when I multiply them together, I have to get a negative 6, so one of them needs to be negative. And when I add them together, they still need to be negative, so the bigger one must be negative. So we're going to have x plus 2, x minus 3. None of this should stump you, because at the end of the day, you can always use the quadratic formula. As long as you know that, you can always do this step. All right, so that means that we have x-intercepts at x equals a negative 2 and x equals 3. In other words, we know 2 points that are on the graph. We know 2 points, and that would be 0, negative 2, and 0, 3. Those are 200% points that are on this graph. Now we're just going to make a very, very rough sketch of this graph. And how rough? We're just going to plot these 2 points. I'm not even going to plot the vertex. All we need to know is, does this graph open up or does it open down? And that's my question I'm proposing to you. Does it open up or does this graph open down? Brian? That's exactly it. The number in front of the x squared is positive, so it's going to open up. So when we get to this rough sketch, we're going to plot those 2 points, but first we're going to go, oh, it opens up. And that's because our a equals 1. It's positive. If it's negative, it opens down. You have to know this. All right, now to make our rough sketch, we're going to plot our x-intercepts, or our y-intercepts, I should say, which are at negative 2 and 3. So let's go ahead and we'll go negative 1, negative 2, positive 1, positive 2, positive 3. So at negative 2 and positive 3, we have our 2 points that we just came up with. There's only one way for this graph to work. It's quadratic, so it's just a U-shaped. The U-shape has to hit both of these points, and it has to open up. So the only way this graph could work is if the U-shape went through both of these and looked something like that. Now, just a quick reminder, anything above here is where our y value is bigger than 0. Anything below this line is where y is less than 0. So we go back to the problem. The problem says, when is x squared minus x minus 6 greater than 0? When I plug a number in, when is it going to come out as a positive answer? Well, if I plug negative 3 in, I'm going to get some positive answer. If I plug negative 4 in, I'm going to get some positive answer. When I plug negative 2 in, I get out 0. When I plug in negative 1, I'm going to get out some negative number. 0, negative, 1, negative, 2, negative, 3, 0, 4, positive. So what we're looking at is anything along here are going to be positive outputs. So now we're just supposed to list those solutions in interval notation. I do want to put a little note on that. So we have x squared minus x minus 6 is greater than 0. There is no equal to sign. So that means you are going to strictly use parentheses. If it was greater than or equal to, you use brackets. If it's just greater than you're going to use parentheses. So our answer is then going to be our furthest left. We're always going to use our x values. The only time you use y values is for range. So we're always going to use our x values. How far left does this green line go? It goes forever left. So then it goes negative infinity up until negative 2. So we're going to have negative infinity up into negative 2. And we're going to union that with, well, it starts back up at 3. To infinity. And once again, I'm going to use parentheses because it's a strictly greater than sign. It's not greater than or equal to. If there's an equal to sign, I use brackets. No equal to sign, use parentheses. All right. I want you to go ahead and try this one. I am going to note that it is not factorable. It is not factorable. Completing the square, or probably not going to complete the square. I mean, you could, or you could use the quadratic formula. Your choice. Either complete the square or do the quadratic. All right, wherever you're at, let's just look up here. So I used the quadratic formula. If you completed a square, for those that completed a square, it looked like you did it really well. It's not that bad of a process. You just factor it out, kind of like we were doing in vertex form, and then we solve. So it's definitely possible, especially if you forget your formula. All right, then it says to make a rough sketch of this. So that's where I approximated. It's about 3.3 and negative 1.3. It's not a huge deal that you make your rough sketch 100%. We just want to figure out, is it between two numbers, or is it negative infinity to a number and then a number to infinity? That's really our goal. So in fact, me knowing that it opens up, correct? It opens up because we do have 2, a positive 2. So it's going to open up. Our A equals 2. I already know what it kind of looks like. It's just a U shape that does this. And less than would be between the two numbers. So I'd actually know the answer. Let's go ahead and go through this, though. So this is about 3.3 is our first one. So what do we have? Negative 1.3. So let's make this negative 1. Negative 2, 1.3 would be about here. Then it says 3.3, 1, 2, 3, 4. Maybe about here. And it does open up. So we're looking at a graph that looks like... Oh, that was horrible. But it looks something like that. And then we go back to the question. The question says, when is this less than 0? In other words, when do I plug in a number and get a negative value out? Well, if I plug in that negative 1.3, I get 0 out. If I plug in negative 1, I get a 0. I get a negative out. If I plug in 0, I get a negative out. If I plug in 1, I get a negative out. 2, negative. 3.3, I get 0. Anything bigger than 3.3, I get a positive out. Anything less than this, I get a positive out. So the answer I'm looking for is everything between those 2 points. That's where it's negative. Once again, anything that green going down is where y is less than 0. Anything up here would be where y is bigger than 0. They're looking for less than 0, so I shade in this section. And our interval notation is between the 2 points. So our lower end point would be that 2 minus square root of 22 over 2. And our upper end would be 2 plus square root of 22 all over 2. I think that is the easiest way to do inequalities with a quadratic formula, knowing that it's U-shaped. And it's either going to be negative infinity to your lower bound, and then upper bound to infinity, or it's going to be between those 2 points. You just have to recognize whether it wants negative or positive and what it has to do with your graph. All right, the last thing we're going to do is an application problem. We have, if 100 meters of fencing will be used to fence a rectangular region, then what dimension for the rectangle will maximize the area of the region? You might be able to just reason your way through this one. All right, but there's definitely problems, specifically the one I put on the test last year, that wasn't reasonable. You actually had to do all this work, so make sure you pay attention. So first of all, so we have a fencing. We have fencing. Let's go ahead and draw the fencing, because sometimes that's nice. So we have a fence, and we have 100 meters of it. Now, a fence has a length and a width. And when I add all the way around, I get 100 meters. In other words, its perimeter is 100 meters. Well, that means we would have to have 2 lengths plus 2 widths is going to equal 100 meters. In other words, length plus width equals 100 meters. That's the distance all the way around. Now, what they're looking for at the end of the day is maximizing an area of our region. Well, area is length times width equals area. Well, as it stands right now, there's no way to use this 100 in this formula. I can't put this 100 in place of area, I can't plug it in place of width, and I can't plug it in place of this length. So what we're going to do is we're going to rewrite either length or width in terms of the other variable. And you'll see why in a second. So I'm just going to solve everything for length. That means I'm going to get everything on one side and just an L on the left-hand side. So we're going to start by subtracting 2W from both sides. So we'll have 2L equals 100. Don't want the W in front. I guess it really doesn't matter. All right, minus 2W. Then we're going to divide everything by 2 to give us L equals 50 minus W. And the whole reason we did that is because now I can take that 50 minus W and I can write that in place of that L. Well, if we do that, we are then going to have, instead of L, we're going to have 50 minus W times W equals our area. Well, when I distribute that W and change the order just a little bit, we are going to have negative W squared plus 50W equals our area. Well, what type of graph is that? What type of graph would that be? Yeah, a parabola. It's a parabola that's opening which direction? Rena.
Downwards.
It's opening downwards. Well, a downwards facing parabola has a maximum. And our goal is to maximize this function. I want this W to be as big as possible. So once again, this is just a parabola opening downwards. So this right here is just a parabola or a quadratic where a value equals a -1 so our vertex is our maximum. It has a maximum, which will be our vertex. So I need to find that vertex value. Well, how do I find a vertex? How do I find the x value of a vertex? Whew, I can wait. Let's look through our notes if we don't know. Would just be -b over 2a. And then we'd have f of -b over 2a there. Well, that means to find our vertex maximum value, we're going to use -b over 2a. Well, in this case, this is normally my x value, right? In this case, this will be my w. And this result right here will be my area. So w is just going to equal -b over 2a. That will maximize my value. Well, our b value is 50, so we'll have -50. Over 2 times our a is -1, which is going to equal 25. In this problem, if I plug 25 in, I will get the maximum value out. Anything smaller, I'm going to get a smaller value. Anything bigger, I'm going to get a smaller value out as well. So 25 maximize. My width is definitely going to be 25. How do I then find my length? How do I find my length if I know my width? Brian? Into which equation?
-w squared plus 50w.
Say it one more time.
Would it be the area formula?
So we could plug in the area formula and regenerate something, but what does length equal?
Oh, 50 minus the width.
Yeah, just be smarter about it. Yours would work, so we could plug it into this one, we could find the area, and then divide by 25 and figure out what the other one was to begin with. But it's just much easier to go, oh, I already know my length formula. So length equals 50 minus w, but we said w is 25, so that's going to equal 50 minus 25, which is going to equal 25. So then it says give the greatest area. Either we could plug that 25 in here and here, or we could just do our 25 times our 25. So what's our greatest area? Yep. 625. And it would be, did they give us measurements? Meters, so it would be meters squared. All right, so for all these problems, let's go through the steps once again. First thing is come up with generic formulas. Usually it's perimeter and area. Solve for one of your variables so you can rewrite the term of area with the number in it. So my whole goal is to be able to use that 100 to rewrite my area formula and just have w. Then you're going to maximize, which means you're going to find your x value. In this case, it was our w value, and use that to find your other value. That's how all of these problems flow. You do have a few of those on the homework. We're looking at number 7, 8, and 9. But they all follow kind of the same thing. Be careful on what stuff's given to you. So for instance, if you look at number 7 says a farmer wants to make a rectangular enclosure using a wall as one side and 120 meters of fencing for the other 3 sides. So he has 120 meters of fencing. Note he's already using an existing wall. So there's a wall that is already there, like he's got his barn. Then he's going to make a fence around here. I just want you to be clear that this plus that one is going to be your 120 meters. Don't include that fourth wall because that is already standing. So once again, he's got 120 meters of fence that he can build around this. This is already there, so it saves him some space. All right, questions for me? All right, then you have a few minutes to get started.